So before anything else, let me introduce to the topical workbook for computer science 2210 or 0478. This is the workbook 1 for paper 1, basically computer systems. And as you can see from the table of contents, I've included questions on each and every subtopic from the syllabus along with the mark scheme. And these are some of the actual questions, actual pages as a preview from the workbook. Section 1.1, 1.3, 2.2, 3.2, 5.3 cybersecurity and artificial intelligence. This is just to show you a glimpse of what type of questions are included in the workbook. There are many more questions where these come from, and around 18 to 20 questions on an average are included for each and every topic. A must buy if you want to boost your grade. Similar to the paper 1 workbook, I have designed a paper workbook for paper 2 as well. This is for algorithm, programming and logic for CIEs either 2210 or 0478 GCE or IGCSE Computer Science. As you can see, it contains questions on every subsection of the syllabus content for paper 2 along with the mark scheme, so you can understand each and every question, each and every algorithm. These are some of the few pages from the workbook just to give you a glimpse of what type of questions are included. As you can see, this is 7.1, this is 7.7, 8.3 and section 10 Boolean logic. So a lot more questions are included in the workbook. A must buy if you want to have a very good score in your Cambridge examination. Order now. Assalamu alaikum wa rahmatullahi wa barakatuh. How are you guys doing? I hope all of you are fine. So we were discussing section 1, motion, forces and energy, and we have already discussed section 1.5.1, that was balanced and unbalanced forces. So today we are going to continue with section 1.5, and we would be discussing section 1.5.2 friction and 1.5.3. so let's get on with it. So what exactly is friction? Friction is the force that resists the motion of one surface relative to another. In simple terms, friction is a resistive force that opposes motion, and it is always parallel to the contact surfaces, and it is always opposite to the direction of motion. SI unit of friction is also Newton because it is a type of force. All forces have the same unit, that is Newton, and it is vector quantity. Viscous force or viscous drag or just the drag force, whatever you want to call it, is the equivalent of friction in fluids that resist the relative motion of a body through a fluid. When you're talking about two solids, then we say there is friction, whereas if we are talking about a solid in a liquid or in a gas, then we would say normally for the liquids we say viscous drag, whereas mostly for the gases or for air we call it as air resistance. But basically all these three are the same in their working. All of these three oppose a motion, or they try to slow down a moving body. If the magnitude of the pushing force is equal to the magnitude of the friction, then the object will travel at a constant speed. If you are having a friction of 60 Newton and you are pushing an object with a force of 60 Newton, then the object would move at a steady speed. In order to accelerate, in order to increase the speed, you will have to provide more driving force or more thrust or more pushing force than the friction. When a body is at rest, friction will have to be overcome before the body can start to move. So initial force is at times, initial force is needed to make an object move is usually greater than the force needed to keep a body make a body keep on moving. Advantages and disadvantages of friction. Advantages are it is able to start or stop motion. The ability to start or the initiate the stopping of a motion, and this is used in friction when you apply brakes in your cars. Sorry, this is used in brakes when you apply brakes in your vehicle. Then there are basically two small braking pads which rub against your moving tires, and that causes friction which slows down the car. It prevents slipping when walking. Essential for rolling motion. You cannot roll a ball if there is no friction. Whereas the disadvantages are it keeps on reducing speed of a motion, and it causes wear and tear, and energy is wasted as work is constantly done to overcome friction. Methods to reduce friction: you can lubricate the surfaces in contact, put on some oil or grease, smoothen the surfaces in contact by polishing, place ball bearings or rollers between surfaces, this also reduces friction, or use an air cushion between surfaces, such as you can see in a hovercraft. When there are air cushions between two surfaces, the friction is almost negligible. Driving safely. This is a subtopic of friction, and you need to know about it because this is a part of the new syllabus. The time taking to bring a moving car to rest by applying the brakes is known as the braking distance, because it takes a certain amount of distance before the brakes are fully applied. When a driver presses brakes on his vehicle, the vehicle doesn't stop instantly. It travels for a few meters or for a certain distance before it is completely at rest. That distance between the point that when the driver applied the brakes and the point that where the vehicle is actually stops is known as the braking distance. The thinking distance is the distance traveled while the driver is reacting. Let's suppose a driver saw an obstacle on the road or a speed breaker on the road. Now after seeing that obstacle, the time the driver's brain would take to process the information and then send the neurosignal towards the feet in order to apply the brake, that is known as the thinking distance. Means the time in which the driver was thinking or making a decision that to apply the brakes, that is known as the thinking distance. At constant speed, the thinking distance is proportional to the reaction time. The less your reaction time is as a human being, the more quicker you are in making your decision, the less amount of time would be needed as thinking distance. The longer the reaction time, and the further the car would travel before the brakes are applied. So overall stopping distance is supposed to be thinking distance plus braking distance. They both are added together in order to find the final stopping distance. And the thinking distance depends on the following criteria: driver's degree of tiredness. If a driver is very tired, then his thinking distance or braking distance would be increased. If the driver has taken drugs or any alcohol, again the reaction time would increase. If the driver's eyesight is not good enough, he may or not be able to see a hindrance in time, and he would apply the brakes at the very last moment, hence his thinking time would be greatly increased. And plus the visibility of the hazard. If it's a foggy road, you would not be able to see the hazard or a passenger or a walker, and you would not be able to apply the brakes quicker. A braking distance varies with the road condition and the state of the car. Now before we were talking about the factors that affect thinking distance, now we talk about braking distance. Means what affects after you have pressed on the brakes, then what takes a car to stop longer than usual. Then there are two factors for that. One is the road condition and the other is the state of the car. If the road is wet, like it has just rained, or the road is icy, then when you apply the brakes, the tire would stop moving, but they would keep on sliding over the ice or the water, hence the car would stop far greater than where it should have been stopped. Then efficient brakes and deep tire treads, they help in reducing the braking distance. Whereas load on car is also directly proportional to braking distance. If a car is having 5 passengers, then it would stop. It would have a greater braking distance than a car who's having only 1 passenger, because these two are directly proportional. Then we have something that is known as terminal velocity. We have discussed terminal velocity before as well. Terminal velocity is something that is achieved due to friction. As an object accelerates falling through the air resistance also increases, and this reduces its acceleration. Eventually the air resistance upward is able to match the weight of an object or the pull of the gravity downwards. Once this happens, that the air resistance and the downward pull of the gravity becomes equal, then the resultant force of an object becomes zero. Hence the diver or the object keeps on falling at a constant velocity, which is known as terminal velocity. And if the terminal velocity of an object depends upon the size, shape and weight of the object. If it is a very small but a very dense object, then it would have a higher terminal velocity, and it would fall a longer distance before coming the air resistance is able to match out its speed. Whereas if an object is having less weight and greater surface area, then it would stop very quickly, or it would reach the terminal velocity very quickly. Like you might have seen paragliders or a parachuter. Once a guy opens his or her parachute, then they are almost quickly slowed down, and they then fall at a very slow terminal velocity. Whereas if a ball is dropped from, let's suppose, a 100-story building, then it would take it a very long time. It would have crossed around 40 or 50 floors before it reaches its terminal velocity. So always remember, if it is a small object and it is a heavy object, dense object, it is having greater weight but smaller size or a smaller shape, then it would take long time, or it would cover more distance before it reaches terminal velocity. Normally in cases of a falling ball, or if you throw a ball upwards, normally it is able to hits the ground before it is able to reach terminal velocity. Whereas if it is a big object with less weight or a large surface area, then it would be able to reach terminal velocity very quickly, and then the object would fall at a steady speed or a very slow steady speed, because it would having a very low terminal velocity, very less terminal velocity. Objects falling in liquid behave similarly to those falling in air. They also depend upon size, shape and weight of the object. Next we have section 1.5.3, that is elastic deformation. What happens if you apply force to a spring or a stretchable object? So for that, the first thing we have is known as Hooke's law, and Hooke's law states that within the limit of proportionality, the extension produced in a material is directly proportional to the weight or the load applied, and the SI unit of elastic deformation or extension in short is supposed to be Newton per meter or a Newton meter inverse. Now what is the limit of proportionality? It is the point at which the load extension graph becomes non-linear. Means it is the force that when you apply this amount of force to a stretchable object, it would not be able to go back to its original position. Instead it would be deformed or stretched permanently. The spring and the formula for calculating this extension is supposed to be K equals to F upon X. K is the spring constant, whereas force is the F is the force and X is supposed to be the extension, means in centimeter or meter. That after applying the said force, how many units of length over how many units of length did the spring or the wire or the stretchable material stretched over? What was the change in length of the spring or the stretchable material? Remember this formula. This often comes in handy in O-levels exams. To draw a load extension graph, take extension on x-axis, and always remember, whenever you're drawing a graph, write down the name of the quantity, put a slash mark, and then write its unit on both axes. So we usually take extension extension in centimeter or extension in meter on x-axis, whereas we take force in Newton on y-axis. We often call it as load as well, so you can simply write load slash n. Okay, now this is not always the case. As you can see, I have taken a sample graph from past papers, and over there the Cambridge examiner has drawn it as extension on the y-axis, and whereas the load or the force is on x-axis. So this is a general idea or a common tip, but you don't always have to follow it. Use the provided values. You would be given values for force and extension, and then you simply jot down the points and you would connect them together with a pencil. And the limit of the proportionality on an extension load graph or extension force graph would be defined as the point like over here, the point where the straight line becomes bendy or becomes curved. This would be known as, this point would be the limit of proportionality, because beyond that point the object would be deformed permanently, or it would not be able to go back to its original position, as the extension is no longer proportional to the stretching force or the load. So remember this, on extension load graph you have to often mark the point of the limit of proportionality. So always remember, as long as it is a straight line, or at the very end of the straight line, you would mark the point that this is the point of limit of proportionality, or this is the limit of proportionality. Now let's have a look at an example question. This figure shows apparatus used to obtain the reading for a graph of force against extension for a spring. The mass added to the pan produces a force that stretches the spring. Describe how the scale is used to find the extension of the spring. Simply, we take the reading with an empty pan, like when the spring is in original position, and then we take a reading with some mass in the pan, means by applying some weight or some force or some load on the spring. We take both readings for using the same scale, and then we minus them to find by how many units the spring has extended. Read the distance between two marks on the scale with different masses. That is also a way. Or simply take one reading with no masses and the other reading with full of masses, and then just minus the two lengths on scale, and you will know the extension, that by how many units did the spring stretched. Now figure 1.2 shows the force extension graph for two different springs. So this is the extension and this is the force. A student states that spring B is easier to stretch than spring A. Use values to explain what the student means. Spring A has a steeper line, and for a force of, let's say, 10 Newton, spring A was stretched 2 centimeters, whereas spring B was stretched more than 2 centimeters. Now let's check another value. For an extension of 4 centimeter, spring B is somewhere around 15 Newton, whereas spring A is somewhere around 20 Newton. So that means for producing the same amount of extension, we needed to the student had to provide spring A with more force. Hence we can conclude that for the same amount of force, spring B is stretching more, whereas spring A is stretching less. Hence spring B is easier to stretch. We have taken 2 points and we have just discussed that for a force of 10 Newton, spring A is stretching 2 centimeter, whereas spring B is stretching almost 2.5 or 2.75 centimeters. For a force of 20 Newton, spring A is stretching 4 centimeter, whereas spring B is stretching more than 5 centimeters. So spring B is easier to stretch. When a force of 25 Newton is applied, spring B reaches its limit of proportionality, but spring A does not. Explain how figure 1.2 shows this. Graph for figure spring A is a straight line. There is no bend, there is no non-linear shape at the 25th mark, whereas right after over here, means this is the line for 25 Newton, the graph for spring B becomes non-linear. It is showing a little curve, a little bend. That means spring B has reached its limit of proportionality. Graph for spring A is a straight line, while spring B has become non-linear. This would be non-linear. Sorry for the typing mistake. This would be non-linear, not linear. So I hope you have understood 15.2 and 15.3. If you have any problems, feel free to comment them below and I'll make sure to reply them. And I'll see you guys in the next lecture. Take care. Allah Hafiz.